Hi guys, welcome again to my chemistry YouTube channel called Mr. B's Chemistry Embassy. So what am I going to be teaching you guys today? So it's going to be really short, quick, and simple and sweet. So today is just going to be a quick notation about electron configuration. You know, sometimes you may have questions that would ask you, write the electronic configuration of a certain element, and it's really easy. I'm going to show you how easy it is to write configuration. So there are some things that you guys should remember, you know, and there is actually an easy way to do it as well. So know that there is a certain format that we usually follow. So to write a configuration, so we always write the subshells. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, and so on. But to make it really easy, so this is the first thing that you guys should remember. You should remember that all these subshells, they can contain a maximum number of electrons. So we have 4 shells. It's called the SPDF. So it's called what? S, P, D, and F. So that's what we call it. We call it SPDF. So this SPDF, so S can have a maximum of 2 electrons at the orbitals. So P can have a maximum of 6. D can have a maximum of 10. And F can have a maximum of 14 electrons circulating the orbitals. So let's take one element. So let's say carbon. So also one thing that you guys should remember is that you will know that carbon has 2 numbers. So either way it's written. So the first number is 6 and the other one is 12. So who can tell me what 6 represents and what 12 represents? So if pause the video. All right. So if you say 6 represents the atomic number, you're very right. And if you also say 12 represents the atomic mass, you're correct. So either way you write it, either way you see the numbers. So sometimes the bigger number, they'll put it on top, and sometimes the small number, they'll put it below. So it doesn't matter. Just know that the small number is always the atomic number and the big number is always the atomic mass. Now, so to write the electronic configuration, we always use the atomic number. So don't forget that. We always use the atomic number. And how do we write an accurate configuration for carbon? So now that we know that we use the atomic number, so we're going to use 6. Now, so let us write our orbitals out first. So whichever one we didn't use, we're going to cancel. So let's start by doing 1s, 2s, 2p, 3s, and 3p. Okay. So now, so let's start. So we put our 6 right here. So let's go to the first orbital. So we see that it's 1s. We know that S can have a maximum of 2 electrons. So we'll put our 2 here. So don't forget, we'll take our 6, we'll take our 2 from our atomic number. So just to make sure that we know how many electrons is left. So 2 minus 6, we have 4. Boom. So we have 4 left. So the aim is to get to 0. Now we go to the second level. And we see that the second level has S again. We know that S can have a maximum of 2. So we'll put our 2 right here. So don't forget, you're going to take your 2 that you used, you're going to take it from the 4 right here. So we have what left? 2 left. Very good. So you move to the next level. So you see that you are encountering 2p. Remember, p can have a maximum of 6. But how much electrons do you have here? You have 2. So whatever you have left, you're going to put it right here. 2. So we're going to take our 2 from 2. So we have 0 left. Very good. So we have 0 left. Now, so since we have 0 left, so whatever level we didn't use, so we're going to cancel it so that you don't forget. So we cancel the 3s and 3p. Now, so to double check if what you did is actually correct, so you're going to add all these subscripts right here. So 2, 4, and 6. So when you add all this, you must get back your 6 atomic number. So 2, 4, 6. So we are able to get our 2 back. So that means this is the electron configuration for carbon. So it's going to be 1s2, 2s2, 2p2. So 2, 4, 6. So that means we are correct. So that is how to write the configuration for carbon. I know it's going to be a little fast, but you could always go back to watch this video. All right, so let's do one more example. Let's say, so let's do calcium. So calcium, so can everyone tell me what the atomic number of calcium is? Pause the video and tell me. All right, very good. So if you say calcium has an atomic number of 20, you're correct. So, all right, so let me clean this off real quick. Okay. Oops, excuse me. All right, so calcium has what? Calcium has Ca. Calcium has 20 and atomic number 40. So 20 atomic number and 40 atomic mass. So let's start now. So let's start by writing out our level. So let's say 1s, 2s, 2p, 3s, 3p, 4s. So 4s, we keep on going. 3d. Very good. So we may end up using more or less. So let's start. Now we know that, so let's put our calcium right here. So we know calcium has 20 atomic number, right? So let's put our 20 right here. Okay, so let's start. So the first level is S. We know that S can have a maximum of 2. So we'll put our 2 here. So we'll take 2 from here. So we have 18 left. So remember that we're going to go all the way to 0 electrons. Now, so we go to the second level, we see that it's 2s, another s. S can have a maximum of 2, right? So we'll put our 2 here, we'll take 2 from here. So we have 16 left, 16 electrons. So remember, we keep on going until we get to 0 electrons. So we go to the next one, we see it's going to be 2p. Remember, 2p, p can have 6. So we put 6 right here. Remember, we're going to take our 6. So we have what? 10 left. So we keep on going until we get to 0 electrons. So we go to the next one. The next one is 3s, another s. S can have 2, right? So put 2 here, we'll take 2 from here. So we have 8 left. So we keep on going. So we go to the next one. It's 3p, right? P can have 6, right? So put 6 here. So we'll take 6 from 8. So we have 2 left. Remember, we keep on going until we get to 0. So luckily, the next one is going to be 4s. So s can have maximum of 2, and we have 2. So we're going to put 2 here, and we'll take 2 from here. So we have 0. So we have 0 electrons left. So we end up not using the 3D. So we're going to cancel the 3D, right? So the next thing is to check if our answer is correct. So how do you check? You have to add up all these subscripts. So they must be equal to what? If you say 20, that's correct. So let's add. So 2, 4, 10, 12, 18, 20. So that's correct. So after adding, we are able to get back our 20 atomic number. So this is going to be the electron configuration for what? Calcium. So this is calcium, and this is what? This is what? Carbon. See. So So that is how simply to write the electronic configuration. So the first thing you have to do, you have to make sure that you write this in order. So that is the first thing. Then second thing, when you get your element, so you go to the periodic table and look for the atomic number. Remember, we always use atomic number, not the atomic mass, and the atomic number is always the smaller number. Then after that, then you now start going to each level and seeing, oh, how much can S take? What is the maximum electron P can take? Maximum D can take, and maximum F can take. Remember, S can take 2, P can take 6, D can take 10, and DF can take 14. So that is how you get your configuration done. Easy, sweet, and simple. So if you're still watching this video, so that tells me that you're probably getting some, value from it. So what I want you guys to do now is that it's just going to take you a few seconds. Subscribe, smash the like button, share this video so that YouTube will be able to push this video out to more students, and it's going to benefit them. And also, you could make a comment down below to tell me how you are enjoying this video or what other topics you would like me to post. So I've not posted in a while, but now I'll be trying to post regularly. So once again, it's Mr. B's Chemistry Embassy. This is electronic configuration, and this is how easy it is to write it. So until I see you guys next time, don't forget, subscribe, share, smash the like button. I'll see you guys next time. All right, bye.